So enthalpy kicks off module 3 of the final, the long paper. So what is enthalpy? Well, enthalpy is our posh word, as chemists, for energy. It's chemical energy. So enthalpy is chemical energy, and we give it the symbol capital H. So enthalpy is chemical energy. What do I mean by chemical energy? What chemical energy? Chemical energy? Yeah, it's the energy in the bonds. So the energy that's in the bonds. And it's given the symbol. So in a chemical reaction, we are looking at changes in enthalpy. We look at changes in the chemical energy. How do you often observe changes in chemical energy as a chemist? What do you feel? It gets warm, doesn't it? It can get warm or it can get cold. So, enthalpy is chemical energy given the symbol H. During a reaction, so during a chemical reaction, changes in enthalpy occur. What symbol do we use for change? Mathematicians. Delta. They're big changes. If it's a measurable change, it's a capital delta, which is a triangle. Change enthalpy occur. So that's got the symbol delta H. That is what we're going to be looking at, delta H changes. Remember, that energy cannot be created or destroyed. So the chemical energy has to be converted into something else, into another form of energy. So chemical energy is often transferred, we said, to heat energy. What other types of energy can it become? Light energy, yeah, but also light. What else? What else? Well, if I can speak. Think fireworks. Well, some of it's connected together. Sound energy. But mainly, it's heat energy. Heat energy is what we measure. So, the first type, this is the most common type, exothermic reactions. Exothermic reactions, these occur when the temperature increases and if it increases, it means that energy and chemical energy is converted into heat energy. So, what's happening to enthalpy? Is the enthalpy, the chemical energy, increasing or decreasing? Decreasing, brilliant, because it's being converted into heat energy. So enthalpy decreases. Now I imagine you've drawn little reaction profile diagram before. Let's do an example of an exothermic reaction. The one that you're probably most familiar with, methane, which is the stuff that comes out of the gas taps, plus oxygen, giving carbon dioxide and water, like so. So to do an enthalpy, we're going to do the enthalpy profile diagram for this. Along the x-axis is called the reaction coordinate. Going up here is going to be enthalpy. On this line, this is my reactants. My reactants are going to be CH4 plus 2O2. On my products, is the enthalpy of my product going to be higher or lower? Going to be lower, enthalpy is decreased. So that goes there. So this difference here, that going down is delta H. And delta H is going to be a negative figure, is negative. Please note, do not ever use a double-headed arrow. It's a single-headed arrow going down. Some people love the double-headed arrows, don't go there. They won't like it. Single arrow down. That is an exothermic reaction. You put your reactants here, products there, goes down, sorted. So endothermic reactions, we can take the same statement and just turn it around. Endothermic reactions, these occur when the temperature decreases and heat energy is converted into chemical energy. So enthalpy increases. So we'll do an enthalpy profile. I'll tell you what, let's do an example first. Let's be consistent. So an example. Sometimes they often ask you to do an example, and it stumps people with endothermic reactions. One is going to be the thermal decomposition of a metal carbonate. Probably the easiest, well, one of the easiest ones to remember is actually photosynthesis. So an example is going to be carbon dioxide plus water goes to glucose plus oxygen. Probably, just you've got to remember too what an example of an exo and an example of an endothermic. Yeah. So if we do an enthalpy profile diagram for this one, so we have a reaction coordinate going on there. We have enthalpy going up here, and now put my reactants again here. Enthalpy is going to go up to give me my products there. Remember, single-headed arrow going up. So delta H now is going to be a positive figure because my enthalpy is increasing.